Hey guys, Mr. T here, just doing another set of solutions, this time for the 2021 General Maths exam for SACE. So let's get started. Question 1. Testing has been carried out on the length of time that a new brand X smartphone battery will work. Before it switches off, a large number of brand X phone batteries were tested. T was found to be normally distributed with a mean of 16.3. Standard deviation 2.4, graph below, write a number in each box to provide a partial scale for the distribution of brand X, 16.3 hours, 16.3 plus 2.4, this is going to be 18.7, take 2.4, go back to the beginning, take 2.4, 13.9. Calculate the percentage of brand X batteries that could be expected to last less than 15 hours. So the percentage, therefore we're doing a normal CDF. Less than 15, so negative E99, negative infinity to the left. 15 is the highest we care about. 16.3 and standard deviation 2.4 equals negative E99 is already there, 15, 16.3, 2.4, 0.2940 to 4 decimal points. Therefore, 29.4% expected to last less than 15 hours. If 834 brand X batteries were tested, how many could be expected to last less than 15 hours? I already have the decimal point there for less than 15. 0.294 times by the 834 batteries. We got 245.196, therefore 245 batteries expected to last less than 15 hours. Brand X advertisers claim that 90% of their phone batteries will last at least T hours. Circle the letter of the graph below that represents the claim. At least means greater than or equal to. So the only greater than or equal to's are C and D, but we want 90%, which is the majority of it, which is going to be D. Calculate the value of T, give your answer correct to at least one decimal place. So if you have an older calculator, you'll be, no, not normal CDF, in norm, but your calculator doesn't allow you to adjust the direction of the tail, so you're going to go 0.1, 16.3 and 2.4. This is a new calculator here, so I want to show both ways. The older calculators do not allow you to set the tail direction. It's always to the left, so you would be stuck with going 0.1, 16.3, 2.4, tail left, 13.2 to 2 dp. Or if you have the newer calculators, you can set it to 0.9, 16.3, 2.4, tail to the right, and you should get the same answer. 0.9, 90% of the batteries are to the right, where is that boundary set? 13.22 to 2 decimal points, therefore 13.22 hours. Two different ways there, depending on if you have an older Texas Instruments calculator. The manufacturers of brand X batteries extended their testing to include two rival brands. Mean 18, 3, mean 21, 4. Circle the letter of the graph that represents the distributions of battery for Y and Z. Y has a lower mean, so it should be to the left. So these are in the same place, no good. Y is to the left here, is to the left here, is to the left here. Now we have to judge based on standard deviation. Y has a standard deviation of 3 versus 4, so Y should be narrower. Y is wider here, Y is wider here, Y is narrower here. So circle the letter of the graph. B is the one. Brand Z batteries are more dependent than brand Y batteries. Describe two features of the graph they selected that support this statement. Well, 2 marks, so 2 points. Brand Z graph is centered to the right of brand Y, meaning they have a higher mean, battery life. Another point, even though brand Z has a wider ST dev, therefore less consistent, their spread does not go below the lowest battery life for brand Y, i.e. shortest life Z still last longer than shortest brand Y. 2 points, 2 marks. That's page 3 down. Question 2. And here we go with the super woke names. A lead, a newly graduated accountant, started a job earning $64.30 per annum, decided to contribute 3% income, earning 5.85% per annum, compounding quarterly. Employer contributed 10% into the same account. Payments $19.60 per quarter. A lead does 3%, so 0.03 times by 64.30. $1,812.90. Employer does 10%, 0.1 times 64.30. $6,043. Total per annum. Per quarter, $7,855.90 divided by 4. $1,963.98 to 2 decimal points. Therefore, approx. $1,960 per quarter. Hence, calculate the expected balance in the account after 43 years of a lead working in this job. And 43 times by quarters. Apps, finance, TVM, 43 times 4 is 172. The interest rate is 5.85%. She doesn't start off with anything, or he, or whatever the hell that name is. So no starting amount. PMT, we know is negative 1960 going in per quarter. No, not 1960. I'm going to use my exact measurements. Negative 1963.98. FV is the balance we're trying to find now, so we don't know what that is. That's what we're trying to find. PY and CY are quarterly. So for 172, 5.85 PMT, negative 1963.98 for alpha. Enter. We get negative 4. No, not negative. That flashing cursor is annoying. $1,497,249.28 to 2 decimal point. Therefore, $1,497,249.28 expected balance. State 2 different reasons why the balance after 43 years might end up being higher than you calculated in part B. 2 marks. I'm going to give you a range of possible answers. Earning rate of super fund might increase because investments improved. The economy might have gotten better to help that. Might get a pay rise. Increasing contributions. Might choose to pay more. Might choose to contribute a higher percentage. What else is there? The required super rate might also increase. After some years of working, Elite achieved a balance of $120,000 in the super account. At this time, decided to take a career break for 7 years. During the break, no payments were made into the super account. What interest rate, compounding quarterly, would Elite have needed on her super account if she was to grow the balance to $200,000 over the 7 years? So it didn't make any payments. So it's just going to increase according to the superannuation rate, which we're trying to find. So N is 7 years times by 4, 28 quarters. The interest rate is what we're trying to find. PV was at $120,000 in the account. No payments were occurring because she stopped working. FV, we wanted it to grow to 200,000. PY and CY are both 4. Seven times 4 is 28. Don't know the rate. Started off at 120 grand. No payments. 200,000. 4 and 4. We get 7.36 to 2 decimal points. So would need a 7.36% per annum rate. Lead retires with a balance of 900 grand, places into account, earning 3.65% per annum, compounding weekly. So this is the pension fund. If she still wants 900,000 in the account after retiring for 10 years, how much she can... So basically she's just, or he or whatever, is surviving on interest generated alone to keep it at 900 grand. So, and 10 years weekly, it's going to be 520 weeks. The interest rate is 3.65 PV. It started off at 900,000. We're trying to work out what can be withdrawn. We want the final value to remain the same, so no change, and PY and CY are both weekly, 52. 10 times 52, 3.65. No, 900,000. Stay at 900,000, 52 both. $631.73 to 2 decimal points. Therefore, $631.73 per week. After retirement, decides to withdraw $12.50 per week to live on. So that style of living not good enough. Calculate how many years it will be before the account balance reaches zero. So we don't know how long it's going to take. That's what we're trying to find out. Rate's the same. Started off at negative 900,000. She's choosing to live it up a little bit, or here, whatever. 12.50. We want it to reach zero. PY and CY both 52. PMT is positive because that money's coming out. My calculator's frozen. I need to completely close Chrome. And open it again. Split. Well, this is going to delay the exam. Hopefully I don't run out of time. Okay, start over. TVM. That better not freeze later when I'm doing like a significantly longer question. 900,000. PMT. Positive 1250 because she's getting paid that amount. Account goes to nothing. 52. Alpha. Enter. It says 1,003.27 to 2 decimal points. How many years? So I know how many weeks, but how many years? 1,003.27 divided by 52. 1,003.27 divided by 52. 19.29 to 2 DP years. Therefore, 19.29 years to reach $0. It's page 5 down. 4 items have been donated to a charity auction. Condition auction is any buyer can purchase only one thing. Decide which buyer is successful for each item so the max amount of money is raised for the charity. 4 buyers place bids, hundreds of dollars. Which buyer has made the highest bid on item 2? well, 16 by a 4. Explain what has been done to the original array to produce the one below and why it is necessary to do this. We've done the maximization step. Inverts the original matrix by subtracting all elements from the largest number. It is necessary because the Hungarian algorithm minimizes by default. The normal thing it does is find the minimum optimal solution. We're trying to find the maximum, so we need to find the minimum of the inverted matrix. That is why we did that step. Page 6 done. Carry out the Hungarian algorithm on the array from part B1 until a solution is reached. Show the result. Smallest number in the row, 1. Smallest number, 2. Smallest number, 0. Smallest number, 2. 12, 9, 2, 0, 14, 8, 0, 4, 17, 11, 0, 4, 12, 5, 0, 1. Smallest number is 12, smallest is 5, smallest is 0, smallest is 0. 0, 2, 5, 0, 4, 3, 6, 0, 2, 0, 0, 0, 0, 4, 4, 1. I can cover zeros now. Do it in red. 3, 3, 2 only. 3 lines. There's 4 rows, so I need to do the next step, the smallest uncovered. Leave single covered alone, 0, 4. Add to double covered, 4, 0. Take from uncovered, 0, 1. Leave 2, 3, 4, 0, 2. leave, 2, leave. Cover 1, 2, 3, 2, 2, and 2. Find lonely zeros. Row column, not alone in its row. No, alone in its column, yes. Alone in its row. No, alone in its column, no. Alone in its row, alone in its column, no. Alone in its row, yes. Column row, no. Column, yes. Process of elimination, that's the only remaining one to choose. Fill in the spaces below to complete the interpretation of your solution from part B2. Items 1, 2, 3, buyers 1, 2, 3, 4. Buyer 1 will get item 4. Buyer 2 will get item 1. Buyer 3 will get item 3. Buyer 4 will get item 2. The charity will raise. Is that the combo? $700, $1,600, $2,300, 2200. 0, 0. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 2, 4, 5, $6,800 from the auction. Question 3 still going. That's page 7 down. Before the day of the auction, item 4 was withdrawn from sale. They allowed buyer 2 the chance to purchase 2 items. The buyers were then allowed to change their original. As a result, a new initial array has been produced. The bids are repeated in row 3. 2 dummy columns have been added. They performed the Hungarian algorithm with the result shown. It's ready to be used to assign items to buyers, and multiple solutions are possible. We'll select zeros. 4, 4, 3, 2, 2. Row column, row column, row column, row column. Oh, very difficult to choose anything here. Well, if we ignore this, which are the dummy rows, for our choosing, it makes it less complicated to choose. The only way, there's no zeros here. There is a 0 here, so we can deal with this person grabbing that row. In these 2 columns, these zeros are matching in these 2 rows. The only difference is this 0 here, which he can deal with. Why can't it be this 0? Because we already selected that. So process of elimination, the only other selections that can be made are these 2. Buyer 2 getting item 1. So in all possible solutions, what can we see? In all possible solutions, buyer 1 will get item 3. That's definite. That's not one of the multiple optimal solutions, because the multiple possibilities is here in the dummy links. So buyer 1 will get item 3. State another outcome which is the same in all possible solutions. You could also say buyer 3 will get item 2. Also state another outcome which is the same in all possible solutions. You could say what I just said there. Also buyer 4 gets nothing. Calculate the difference in the total amount of funds raised for the charity as a result of the changes made above. So what do we have in the selection? Buyer 4 gets nothing. Calculate the difference. 2400 plus 1750 plus 1750 plus 800, 2400 plus 1750 plus 1750 plus 800, 6700. Therefore, $100 less raised for charity. It's page 8 down. And we have now statistics. The scatter plot below shows the temperature plotted against humidity. Higher the temperature, lower humidity. At 24 hours, linear model was fitted. They got the least squares regression line. Considering the info above, which statement below best fits the linear model? There's a moderate linear correlation. Well, 0.929, the square root of 0.929. That's not moderate, that's strong. So not the top one. The y-intercept for the model occurs at negative 4.68. No, negative 4.68 is the slope. The r value of the least squares regression line will be negative. That is the true one because it is a negative linear relationship. Interpret the slope of this least squares regression line in context of the problem. For every 1 degree increase in temperature, the humidity decreases by, the humidity is in percentage, so 4.68%. That's in context. Following data was recorded over the same 24-hour period at another weather station. Use a linear model. Okay, I have to chuck this data in. Start, edit, 15.6, 16.3, 17.8, 19.7, 21.3, 22.7, 23.7, 18.1, 18.9, 15.7, 12.1. 66, 61, 52, 46, 39, 34, 33, 56, 75, 78, 84. Find the r squared value. Stat, calc, lin reg. Because it's set a linear model. I don't have my diagnostics on, so second 0 for catalog. Press matrix button to skip down to the diagnostic. Well, the D entries. Turn diagnostics on. Start calc, lin reg again. Find the r squared value. R squared equals 0.7924 to 4 decimal points. Which of the following 3 points from the data is most likely to be an outlier? Tick the appropriate box to indicate your answer. I'd normally want to just draw this on a grid. What do we have here? 15 and 16, we're at 60, 17, 50. So almost like for every 1 the temperature goes up, it's going down by 10. So 18, start of 18 is 56, so that's still reasonable. But then we suddenly have It's still around the 18, and then it jumps back up to 75, a really high humidity. Okay, because this fits with the trend. 15.7, still quite high. But here, the higher temperature, it's jumped back up to 75. So that's the most likely. If you're really unsure, come back to it. Draw a very quick sketch of the graph on some extra grid paper. The outlier has been found to be the result of a recording error. Remove the point chosen and calculate the new least squares regression line. Stat, edit, 18.9 and 75. 19.9, delete. 75, delete. Stat, calc, linreg. The new equation is going to be relative humidity is equal to negative 4.75 times by the temperature plus 141.76. This was rounded to 2 decimal points. Use the equation to predict the temperature when the relative humidity is 100. Okay, 100 equals negative 4.75 T plus 141.76. The opposite of adding 141.76 is taking, so 100 take 141.76. Negative 41.76 equals negative 4.75 T. Opposite of times by negative 4.75 is dividing by negative 4.75. Do that to both sides. That cancels, so T, negative 4.75, 8.79 to 2 decimal points. Therefore, 8.79 degrees C for 100% humidity. The relative humidity when the temperature is 32, H is unknown, negative 4.75. Temperature is 32 plus 141.76. H equals negative 4.75 times 32 plus 141.76. Negative 10.24. Percent at 32 degrees C. Page 10's done. The predictions made in part F1 and F2 are both explanations. Complete the statement below. Prediction made in part which is the least reliable? Time 8.79. Not time, temperature. 8.79. The lowest number we had was 12. So 8.79 was around 4. Extrapolation of 4 away from the lowest bit of data. Temperature is 32. Degrees. Do we have any 32 degrees? Yeah, so part 1, the prediction made in part 2. Part 1 is more reliable because part 2, because the extrapolation is over 8 degrees Celsius from the closest data point versus only 3 degrees Celsius in part 1. Also produces a negative humidity, which is nonsense. Negative humidity percent, which is nonsense. It's unrealistic that way too. The prediction made in part 2 would be less reliable because it's more of an extrapolation. Also, it produces a nonsense answer of negative 10.24%. Page 11 done. Question 5. Ryan wishes to invest some money for 4 years. The local credit union has given him 3 options. 2.07% per annum, fortnightly, 2.1% per annum, compounding annually, 2.15% flat rate. Calculate the effective rate of interest for option A and for option C. Option A, EFF, apps, finance, EFF, 2.07, compounding fortnightly, 26. 2.07, 26 equals 2.09 to 2 decimal points. Therefore, 2.09% per annum effective. Option C. It's an interest, simple interest. We haven't been given an amount, so I'm just going to do $100 times by 0.0215 times by 4 years. 100 times by 0.0215 times by 4. It's going to earn $8.60. So plugged into a compound interest situation, 4 years. Interest rate is unknown, that's what we're trying to find. You put in $100, invested, no payments, you were just growing it by compound interest. FV, it grew to $108.60. PY and CY are both compounding once a year for the effective rate. Apps, finance, TVM, 4. Unknown, negative 100, 0, 108.6, 1 and 1. So 2.08 to 2 decimal points. Therefore, 2.08% per annum effective for option C. Hence, tick a box to indicate which of the 3 options Ryan should select and provide a reason for your choice. Option B, it's the highest rate. Effectively, why? Because this is already the effective rate. Provide a reason for your choice. Option B, compounds annually. So its effective rate is the nominal rate of 2.10% per annum, which is the highest of all options. Ryan has $5,000 in savings. He decides to invest in another account, paying 3.28% per annum, compounding weekly. Deposits $45 each week. show that Ryan will have approximately 15,700. N. 4 years times by compounding wheel here, 52. 208. Interest rate is 3.28%. PV. He put 5 grand in the account, so negative 5,000. He's making $45 payments, so negative 45. Solving for FV, we want to know what's going to be in there. After 4 years, PY and CY, he's paying weekly. It's compounding weekly, so PY and CY are both 52. 3.28, negative 5,000, negative 45. Alpha solve $15699.15 2DP. Therefore, approximately 15,700 in account after 4 years. Calculate the amount of interest earned in the account over the 4 years. Well, the interest of an investment is equal to what it grew to, $15,699.15, minus all the money that was put in. So he put in $5,000 and 208 payments of $45. $208 times by 45. It's going to be 15,699.15 minus 208 times 45 plus 5,000. Take 14,360. 15,699.15 minus the answer, $1,339.15. Interest earned in the 4 years. Page 12 done. If Ryan doubled his weekly deposit from the time he opened the account, state why the interest calculated in Part B would not, Part B2 would not double. Interest earned compounds on the starting balance and payments. He only doubled the payments, not the starting principal. That's why I wouldn't double. Ryan is planning to travel in 4 years' time using the money from his savings account. The holiday he's planned would currently cost him $14,000. Assuming that the cost of the holiday increases with inflation, what is the maximum average annual inflation rate that could occur over the 4 years so that the cost of Ryan's trip rises to no more than $15,700? This one's tricky. You're given multiple choice. Okay. So one way you could do it is inflation formula. Indexed. For inflation, currently costs $14,000. Let's try all the rates. 1 plus 0.0289 to the power of 4. 1.0289 to the power of 4 times by 14,000. $15,689.92 to 2 decimal points. That's below 15,700, so not the maximum just yet. It's the first one, indexed 14,000 times by 1 plus 0.029 to the 4, 1.029 to the power of 4 times by 14,000, 15696.02, 2 decimal points, still hasn't exceeded 14,000 times by 1 plus 0.0291 to the 4, 1.0291 to the power of 4 times by 14,000, 15,702.12 to 2 decimal point. That's gone over 15,700, therefore 2.90 max inflation rate of 2.90% per annum. That's one way to do it. You could use TVM Solver probably as well. How could we do that? TVM Solver. Apps, Finance, TVM Solver, 4 years. We chuck 14,000 in there. No payments. We don't want it to go past 15,700. Inflation compounds once a year. Find the rate. The line is 2.906. So the line is 2. If we go beyond 2.906, which is 2.91, it's going to be higher. 2.90 is just below the 2.906 that we've got in the graphics calculator. So yeah, you could do it with TVM Solver as well. I just chose to do it this way. You get the same answer anyway. Okay, now that is page 13 down. Tan wants to landscape the garden and has identified tasks that need to be completed. The times needed in days to complete the tasks and the order are shown in the network diagram below. State the tasks immediately preceding task L. L is there, it needs E, it needs C, and it also needs F from the dummy link. So E, C, E, F. Not in the grid. You could, if you wanted to, F dummy link. But you could just say CEF. On the network diagram, carry out the backwards scan. So we're assuming that they've done this properly. 25. 25 take 3, 22. 22 take 3, 19. 25 take 8. 25 take 8 is 7. Yeah, 17. 19 take 5 is 14. 25 take 6, 19. 19 take 0. So we want the smallest number here. 19 take 5, 14. 25 take 8, 17 on the line. 19 take 0, 19 on the dummy link. 19 take 8 is 11. 14 take 1, 13 on the line. 19 take 9 is 10. 19 take 10 is 9. 10 take 2 is 8. 11 take 7 is 4. So 19 take 10, 9 here. 10 take 2, 8 here. 4 take 4 is 0. State the critical path. A, B, G, K, M. Calculate the slack time for task J. J is here, 12 to 17. 17 take 12 is equal to 5 days slack time. Page 14 done. If Tan starts landscaping on the 1st of December, on what date will the garden be finished? Well, it starts on the 1st plus 25 days, 26th December. Finished. Apart from affordability, in the context of the problem, state one assumption made when giving your answer to part D1. Well, we assume no tasks on critical path are delayed in any way. Due to problems with the budget, Tan has had to remove tasks F, H, and J from the plans. This is represented in the network diagram below. This means that task G is now a prerequisite for task L as well as for task K. Represent this change on the network diagram above. Okay, if I did an arrow here, if I made G connect there, that's going to say that L requires E, C, and G like I want, but then this node would be overlaid here, and that would make K also require E, C, and G, but K doesn't require E and C, K only requires G. We need a dummy link here to give L, G, E and C, but K still only requires G. Carry out a forward scan. A backward scan is not required. 0, 4, 6, 9, 10, 11, 12, 13, 14, 15 through E, 14 through C, 4 and 7 is 11, 11 and 8, 19, 19 plus 0 is 19, 19 plus 6, 25, 19, 20, 21, 22, 22, 22 plus 3 is also 25. All the statements below are correct. By ticking one box, select the statement which is the most complete interpretation of the effect that the changes have made. Only non-critical tasks were removed. Removed F, H, and J. F, H, and J were not on the critical path. So that was 1 point. Completion time is the same, plus 1. 2 points. The completion time is unchanged, plus 1. The completion time is unchanged, but the number of critical paths is increased. That's also correct. The earliest start time for task L has increased. 19. Yeah, that's true. Plus 1. Which has changed the critical path. Well, L wasn't part of the critical path in the first place, so the changing of the start time for L didn't cause the change in the critical path. I'm going to call it a minus. the most complete. These two top ones sound so similar. The only... Has the number of critical paths increased? I can only non-critical tasks are removed. There's 3 tasks were removed. On balance, out of these two, I'm going to say this. Not quite sure what most complete means, but because there was 3 non-critical tasks removed, I'll give that more weight than the second option. That one's a bit furry, but I'll put my weight behind that one. Option 1. Question 7. So that is page 15 done. Question 7. Management of a marina investigates borrowing 450 grand. Investigates borrowing 450,000 to refurbish moorings and upgrade the security system. One option available is take out interest-only loan for 8 years, set up a sinking fund, 450 grand, interest-only loan, 8 years, flat rate of 7.3. Okay, monthly SI equals principal 450,000 times by the rate as a decimal times by 8 years. 450,000 times by 0.0739 times by 8, $266,040 in interest over 8 years. 8 years times 12 months. 8 times 12, 96 months. So to get the monthly interest-only payment, divide that by 96. We get $2,771.25 monthly. Sinking fund to be established earns 3.25% per annum, compounding fortnightly. Show the payments. N, 8 years times fortnightly, 26. Interest rate is 3.25%. Sinking funds start with nothing. I'm trying to find the payment. Solve for that. FV, I need it to grow to 450,000 over the course of 8 years. PY and CY. Fortnightly, so 26. Apps, finance, TVM, 8 times 26 is 208. 3.25. Nothing. Solving for that. 450,000, 26, both. Alpha solve. Negative $1895.73 to 2 decimal points. Therefore, approx. $18.95 per fortnight. Because he's literally off by 73 cents. Calculate the total repayments to be made over 8 years by the management for the interest-only loan and sinking fund. Option. They need to pay $266,040 in total for the interest-only loan, plus 208 payments of $1895.73. 208 times by 1895.73 0.73 plus 266,040. $660,351.84 total. As an alternative option, the management considers taking a reducing balance loan with an offset account. After 2 years, the balance owing on this loan would be $351,700. They're going to deposit 15 grand. State the new balance. 351,700 minus 15,000. 351,700 minus 15,000. New balance is going to be 336,700 is new balance. Page 16 done. The interest charge on this loan is 4.35% per annum. Compounding monthly, the monthly repayments would be 5558.74. Show that the balance of the loan on which interest is being charged 6 months after the deposit is made into the offset account would be approximately 310,400. Okay, and 6 months interest rate is 4.35% per annum. PV 336,700. So we deposited 15 grand in the offset account, getting the balance to 336,700. So that's what we're starting here. PMT we've been told is $5558.74. We're finding the balance. So FV, PY and CY monthly 12. Oh, this is quite an in-depth one here. 6, 4.35, 336,700, negative 5, 5558.74. Solving for that, 12 for both. Negative 310,433.75 to 2 decimal points. Therefore, approx 310,400, as you can see, very similar. 6 months after the deposit is made in the offset account, the management will need to withdraw the 15,000, so they're removing the offset. Calculate the remaining number of months. N is going to be unknown. That's what we're finding. Equals 4.35%. PV. So they had 310,433.75 left. But they've removed the offset, so add on the 15,000. We'll find that out later. PMT is negative 5558.74. Paying out the loan, so FV is going to be 0. PY and CY are both going to be 12. 310,433.75 plus 15,000. That's 325,433.75. Nothing at the end of the loan. How long is it going to take? Alpha, enter 65.92 months to 2 decimal points. Therefore, remaining number of months, 65.92 months remaining. Calculate the total amount required to repay the reducing balance loan, and the offset contains 15,000 for the 6-month period. So we had before the offset, two years of payments 2 years of payments is 24 payments. 24 payments, and the payments were $5558.74. Here's a number during the offset. 6 months of $5558.74. After 65.92 months. 65.92 payments, $5558.74. Find these out. 24 times 5558.74. $133,409.76. 6 times 5558.74. $33,352.44 paid during the offset, and then 65.92 times 5558.74. $366,432.14 to 2 decimal points. Total to pay, well, 133,409.76 plus 33352.44 plus 366,432.14. $533,194.34 total to pay. The management investigated 2 options for borrowing the money: the interest-only loan and sinking fund, the reducing balance loan and offset account. What did they pay? Did we find that? Well, they should choose option 2, because the total repayments are, what did it cost for the original arrangement? 660,351.84. 660,351.84 minus the new total, 533,194.34. $351.84 minus the answer, 127,157.50 are $127,150.50 less. It's over $125,000 less for option 2. Page 17 done. Question 8. Partial network diagram below represents the tasks needed to sort mail in a post office. Complete the precedence table below for tasks D, F, and H. D requires A through a dummy link and needs E directly. It requires B, F. What does F require? F only requires A. H requires D and F. Complete the network diagram above by adding the links for tasks C and G. C requires A. And C is not a prerequisite of anything, so it goes straight to the end. G requires A and E, and J requires G and H. So G is going to come out of here, and it's going to be a prerequisite for J combined with H, so G is there. Which one of the statements below is false? Tick the appropriate box. We need false. Either task A or task E must lie in the critical path. Well, they form one of the 2 branches. So that's true. Task A and B cannot both lie That's possibly false. We don't know what the numbers are, so we can't make a judgment on that. Task A, B, and E must all be complete before task D can start. That's a true statement. There is no task which must lie on the critical path. Oh, this is a tricky one. I'm almost prepared to take the hit on that 1 mark. Not quite sure what the answer is. I don't have anything to check it with. I'm just giving you my solutions here. A and B cannot both lie on the critical path. You don't have the numbers to determine that. There is no task which must. I'm going to say this one, question mark. Because that's suggesting that none of the tasks have to be on the critical path. Which is false. There has to be a critical path. And that critical path is made up of tasks. That's an iffy one. Question mark there. If you lose a mark, sucks. But whatever, I don't have any solutions for me to check. I'm giving you my solutions here. And I've explained the thinking there, so do your best. Question 9, last question. Health Department identified an outbreak of a notifiable contagious disease. Data in the table below shows the number of new cases on selected days. The scatter plot for the data is shown below. Circle the letter of the graph which shows the line of best fit for the linear model. A is not linear. C is not linear. B is a terrible line of best fit. So it must be D. Page 19 done. The diagram below shows a residual plot for the linear model on the previous page. It looks pretty good. Above, 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 below, below, well below, well below, slightly above again, and more above. Using the residual plot, give 2 reasons why it would not be appropriate to apply a linear model to the data. There is a clear U pattern in the residuals. Therefore, linear model is not appropriate. Also, residuals are quite large. Also, residuals are quite large. 40, 20, negative 60, back up to 40 again. All right. Although, to be fair, the data is large itself, but you're looking for 2 marks, so you make 2 points. C. 1. Determine an exponential model for the data in the form y a times by b to the power of x, where a and b are constants. I need to check this data into the calculator. Stat, edit, clear, 2, 5, 12, 20, 26, 33, 41, 3, 8, 25, 47, 100, 252, 337. exponential model. Variables appropriate to the context. So the variables are D and C. So the cases, C is equal to 4.04 times by 1.13 to the power of D. Those are appropriate variables. That's rounded to 2 decimal points. Interpret the value of A in the context of this problem. Um, 4.04 cases on first day. Interpret the value of B in the context of this problem. 1.13 minus 1 is equal to 0.13. Therefore, the number of new cases increases by 13% each day. That's for B. D, using the exponential model found in part C1, calculate the number of new cases of the disease that would be recorded on the 60th day after the outbreak started. Cases 4.04 times by 1.13 to the power of 60. Second quit. 1.13 to the power of 60 times by 4.04. You got 6181. .81 to the 6181 new cases on 60th day. You gotta check. That looks weird. This is just taking time out of the thing. That's good. Shows you that how fast you should work. .1254. The power 60. Um, 4.04 times by okay. 6181 new cases on 60th day. Calculate how many days after the start of the outbreak it would take for the number of new cases recorded in a day to reach 10,000. So you graph this. Y1 is 10,000. Y2 is our model, 4.04 times by 1.13 to the power of x, 4.04 times by 1.13 to the power of x. Graph it. We can't see anything, so we zoom out until we can. The intersect is definitely on the screen. Intersect at. Second trace, intersect. First graph was y is equal to 10,000. Second graph was our model. Where do they cross? 63.94, comma 10,000. Therefore, approx. It's close enough to 64 days. Approx 64 days to reach 10,000 new cases. Calculate how long it takes for the number of new cases recorded in a day to double. This is tricky. How long does it take for the number of new cases recorded in a day to double? No, we don't have any other data here, so we're going to start off with 63.94 to reach 10,000. I'm going to do 5,000 here, because that's half. Second trace, intersect. 58.26 to reach 5,000. Let's do 2,500 to reach 2,500. Graph, second trace, intersect. 52.59. What are the differences between those? 58.26 minus 52.59. That was a jump of 5.67. And from 5,000 to 10,000, 63.94. Take 58.26. 5.68. Let's try one more. I'm not sure enough yet. 2,500. 25. That's 2,500. You can't do maths in there. 2,500. 1,250. Try one more just to be sure. Second trace, intersect, doop, doop, doop. 46.92 to reach 1,250. 52.59, take 46.2. Yeah, it's about 5.67. The jumps. Therefore, approx 5.67 days for cases to double. Explain why an exponential model for a contagious disease must eventually become an unreasonable model for making predictions as the disease progresses. Population is finite. An exponential model suggests that it keeps going up and up and up to infinity, but there is not infinity people to get the disease. To get disease. Population is finite to get disease, but exponential model increases to infinity, the model would predict extremely large numbers overestimating who could be infected. Also, disease spreads between people, country borders would halt spread, so there would be deviations from model prediction. Just think of reality versus this perfect model suggesting the number of new cases. Yeah, this is fine at the beginning, but you don't have an infinite number of population, which the model would suggest. And also, this would get halted if you are fighting back. Yeah, that's another idea. Medical systems would fight the disease, changing the shape of the model as well. This is assuming free spread, basically. Assuming. So that's another one. Okay, that's page 21 done. 22 is blank graph. This question was a little iffy. It's either out of those two, question mark, but it's only 1 mark, so it's not too bad. The rest of it seems fine. This is quite a tricky exam. Some things out of left field. Nothing that you couldn't handle with the stuff taught, but you need to think abstractly or rely on other skills that you've built up over high school. So hopefully that helps you out, and I'll see you in the next video. Ooh.